Hi everyone and welcome back to another lab. In this lab, I will configure and verify standard access lists on Cisco devices. As always, I will start by explaining what standard ACLs are, how they work, and where they are typically used in real-world networks. Then I will go over the lab topology and objectives to give you a clear understanding of what we are setting up. And then after that, I will break down the lab tasks step by step. I will also guide you through the configuration process and explaining key commands along the way. Finally, I will do some verification to make sure that the ACL that is being applied is working as expected. So by the end of this lab, you will have a solid understanding of how to implement standard ACLs, control network traffic using basic IP filtering, and apply ACLs effectively on Cisco routers and switches. Okay, so a standard access control list is one of the simplest way to filter network traffic on Cisco devices. It operates by evaluating only the source IP address of a packet and deciding whether to permit or deny it. Unlike extended ACLs, which can filter traffic based on multiple criteria like destination IP address, protocol type, or port numbers, standard access lists, on the other hand, focus solely on the originating IP address. This makes them efficient for basic traffic control, but also somewhat limited in flexibility. Standard ACLs work by matching traffic against a set of rules written in a sequential list. When a packet arrives at a router or a switch, the device checks the ACL entries in order from the top to bottom. If a match is found, the corresponding action, permit or deny, is applied, and the packet processing stops. If no match is found, the packet is implicitly denied due to the deny all rule, which is at the end of every ACL, which is applied by default, unless you explicitly set permit any at the end of the ACL. This means if you are not careful, you might accidentally block traffic that you didn't intend to. In real-world networks, standard ACLs are often used for basic security and traffic management. They are commonly applied to router interfaces to restrict access to specific devices or network segments. For example, an administrator might configure a standard ACL to block certain IP addresses from accessing a management network, ensuring that only authorized hosts can connect to critical infrastructure. They are also useful for filtering routes in routing protocols, allowing network engineers to control which routes are advertised or received. However, because they lack granularity, they are best suited for situations where filtering based on just the source IP address is sufficient. But overall, while standard ACLs are not the most sophisticated filtering tool, they are easy to configure and efficient for basic access control needs. So understanding how they work is essential for anyone managing a Cisco-based network, as they provide a foundation for more advanced security and traffic filtering techniques. Okay, so regarding the lab topology, we have a couple of routers that are running OSPF. Both operates in area 0. So we have router 1 and router 2. They are interconnected with each other via gig Ethernet 0/0/0. Each router advertises all its local networks, allowing all end devices to communicate with each other. So connected to router 1, we have 3 different departments. So as you can see, PC1 and PC2 belongs to the IT department, and both of these devices resides in VLAN 10. On the other hand, we have PC3 that belongs to the finance department and is part of VLAN 20. Finally, we can see PC4 that is part of the engineering department and it resides in VLAN 30. And all of these PCs are connected to switch 1, and switch 1 is then connected to router 1 using a router on a stick approach. And at the top of the topology, you will see a couple of servers, server 1 and server 2, and both of these servers are connected to router 2. So the goal of this lab is to implement standard ACLs to control access to specific networks and to align with the lab objectives, which will be discussed shortly. Okay, so regarding the lab tasks, we will start by testing connectivity between all end devices just to make sure that we have reachability and connectivity between all end devices. Then we're going to move to step number 2, where we are going to block traffic between the finance and the engineering departments. And then next, we're going to jump into step number 3, where we're going to make sure that the finance departments can access only server 1 and the IT departments only. And then we will move to step number 4, where it is quite somewhat similar to step number 3, where we are going to force the engineering department to access server 2 and the IT departments only. And then finally, we're going to jump into step number 5, where we are going to apply rules to ensure that PC1 can reach all other networks, while PC2 will be limited to local communication within its own subnet. And then after that, we will do our verification and save our configurations, and that will be the end of the lab. So before we proceed to the lab solution, if you would like to test your knowledge on this topic, you will find a post linked in the video description below. The post includes lab information and a couple of packet tracer labs, which are provided in a Microsoft document. You can download the document to access both the pre and the post lab versions. Okay, so I'm going to jump into the lab solution now, and I'm going to tackle the very first task, where we need to check connectivity between all departments and ensure that each department are able to reach both servers, server 1 and server 2. So I'm gonna jump into PC1, and then I'm gonna go to desktop, and from there I can go to command prompt, and in here I'm gonna start pinging 10.10.20.10, and we can reach PC3, which resides in VLAN 20. Next I'm gonna ping PC4, so I'm gonna say ping 10.10.30.10. Again, we have reachability and connectivity between the IT department and the engineering department. Next, I'm going to initiate a ping to server 1. Again, I can reach server 1 successfully, and what I'll do next, I will try to ping server 2, which has an IP address of 10.2.2.2. And again, we have reachability and connectivity between PC1 and all other networks. So what I'm going to do next, I'm going to jump into PC3 and repeat the same test. I will also try to ping PC2 just for the sake of completeness. Okay, so I'm going to jump into PC4 and repeat the same test. So the conclusion from step 1 is that all end devices are able to communicate with each other successfully. Now we're going to go to step number 2, where we need to block traffic between the finance department and the engineering departments. So first, we would need to figure out which interface is connected to which department. We would need to log into router 1 and reveal the current interfaces. So let me do that quickly. So as you can see from the show IP interface brief output, we have 3 sub interfaces that have been configured. So we can see gig Ethernet 0/0/1.10. This is the default gateway for the IT department, and the IP address is 10.10.10.1. Similarly, with gig Ethernet 0/0/1.20 has an IP address of 10.10.20.1. And the same applies with the gig Ethernet 0/0/1.30. The IP address is 10.10.30.1. And also, if we wanted to do further clarification, we can issue this command. So show running -config pipe section, and I'm going to say gig Ethernet 0/0/1.20. And you can see that from the description, it does say that this is a link going to the finance department. It uses the encapsulation.1q20, and you can see the network address or the IP address for that network. And if I up arrow this and I'll just include .30, you can see that this sub interface belongs to the engineering department. Okay, so based on the output above, we need to configure both interfaces, gig Ethernet 0/0/1.20, which is directly connected to the finance department, and also we need to configure gig Ethernet 0/0/1.30, which is directly connected to the engineering department. Okay, so what I'm going to do, I'm going to go to global config mode, and then from here, I'm going to say IP access -list. And if you question mark that to reveal the content sensitive help, we have got two options, and we are going to use the standard option. So I'm going to say standard. And at this point, we can also question mark that again. As you can see from the content sensitive help, we have two options. The first one is that we can use a number. Again, it's the access list that we are trying to create. That number must be between 1 all the way to 99. And also we could use a named approach. So we would need to name the access list instead of assign a number to it. So in my case, I'm going to say block underscore and all capital case VLAN 20, and then I'm going to hit enter. And then after that, we will have the ability to deny or permit a particular subnet or network or particular host. So I'm going to say deny 10.10.20.0. So if I question mark this, as you can see, we would need to include the wildcard bits. So I know that this network is /24, which means the wildcard will be 0.0.0.255. And then I'm going to hit enter. And then after this, there is an explicit deny all at the end of the access list, but it is hidden. So I'm going to override that, and I'm going to say permit any. So the first step is being complete. So I'm going to hit exit, and then I'm going to create another access list to block VLAN 30. So I will say again IP access list standard, and I'm going to call it block underscore VLAN 30. And in here, I'm going to say deny 10.10.30.0. And the wildcard is going to be 0.0.0.255. And also, I'm going to say permit any. Now I'm going to hit exit. And so I'm going to tackle the sub interface that is connected to the finance department. So I'm going to say interface gig Ethernet 0/0/1.20. And here I'm going to say IP access group, and then we would need to include the name of the access list that we have configured earlier. So I'm going to say block underscore VLAN 30, and I'm going to say out. And then I will up arrow this multiple times to get to the interface gig Ethernet command. And I'm going to change the last bit from 20 to 30. And then I will also up arrow this multiple times to get to the IP access -group command. And I'm going to change the block underscore VLAN from 30 to 20. And now I'm going to hit end. And now I'm going to perform some post checks. So I will say show IP access list. And you can see that we have configured two standard access lists. The first one is called block underscore VLAN 20. That blocks or denies 10.10.20.0. And then the second one is block underscore VLAN 30. And that blocks this network 10.10.30.0. And also what we can do, we can look at the configurations under interface gig Ethernet 0/0/1. So we can say show run pipe section, and let's get the interface ID. So I'm going to copy that and paste it here. And right now you can see under these two sub interfaces that we have configured the ACL here and the second ACL under interface gig Ethernet 0/0/1.30. So one of the things that I wanted to highlight, why we have used the out option instead of the in option when we configured the access group under the sub interface. You can see here the word out. We could ultimately use in, but the correct option for this particular scenario is actually out. And the reason being is because when the packet originates from PC3 and travels inbound on gig Ethernet 0/0/1.20, which is VLAN 20 sub-interface on router 1, the router processes the packet, determines the destination, which is 10.10.30.10, and forwards it out of gig Ethernet 0/0/1.30, which we know that this sub-interface is is associated with VLAN 30. Since the ACL, which is block underscore VLAN 20, is applied outbound on gig Ethernet 0/0/1.30, it checks the source IP address. So the ACL sees the source is 10.10.20.0 and it denies the packet. Similarly, when PC4 in VLAN 30 tries to reach PC2 in VLAN 20, the packet enters R1 via gig Ethernet 0/0/1.30. The router processes it and determines it should be sent out to VLAN 20. The ACL block underscore VLAN 30 applied outbound on gig Ethernet 0/0/1.20 blocks the packet. This is the reason why the out option would work and the in option wouldn't work. Okay, so we have reached to the point that we need to perform some connectivity tests between the engineering department and the finance department. So I'm gonna go to PC3 and I'm going to initiate a ping to 10.10.30.10. As you can see, we are unable to reach the engineering department from PC3. And what I'm going to do, I will go to PC4 and repeat the same test. So I will try to reach the finance department by saying ping 10.10.20.10. And again, the communication between the engineering department and the finance department are no longer reachable. Okay, so we've managed to complete task number 2. Let's move into task number 3, where we need the finance department to have only access to server 1 and should be blocked from accessing server 2. So I'm going to jump into router 2. So I'm going to go back to my topology and I'm going to go to router 2. And then from there, I'm going to go to CLI. And then what I will do, I'll go to global config and I'm going to say IP access list 20, enter, standard, and then I'm going to say 20, and then I'm going to say deny 10.10.20.0, and the wildcard is going to be 0.0.0.255, and then I'm going to permit anything else. So what we have done so far, we've created an access list, a numbered access list called 20, and we have only denied the finance department. And we know the finance department network is 10.10.20.0, and we are permitting anything else. So what I'll do, I'll exit, and then I would need to actually apply the ACL under the interface that is connected to the server. So I'm going to say interface gig Ethernet 0/0/2, and I'm going to say IP access dash group. We will need to define the access list that we just created, which is going to be 20 in that case. And then we would need to be more specific about whether it's inbound or outbound. In this case, we would need to use the outbound option. So now with that being done, let's verify that this has been applied successfully. So I'm going to go back to PC3. I will try to ping server 1. So I'm going to say ping 10.1.1.2. So we are still able to reach server 1, which is what we want. However, we shouldn't reach server 2 at this point. So I'm going to say ping 10.2.2.2. And you can see that the ACL is actually working and doing its job. So I'm going to just go back to router 2. And here I'm going to say show IP access list. You can see the access list 20 has been created. And you can see that we also are denying this network 10.10.20.0. And you can see that it matches 4 packets, which are associated to the ping request that we just sent. Next, we can move to step number 4, where we need to make sure that the engineering department should have only access to server 2 and should be blocked from accessing server 1. So again, I'm going to go to global config and I'm going to say IP access list standard, and then we're going to specify number 30, and I'm going to hit enter. And here I'm going to say deny 10.10.30.0, and the wildcard is going to be 0.0.0.255. And then I'm going to say permit any. After that, I would need to apply the ACL in the outbound of the interface that is connected to server 1. So I'm going to say interface gig Ethernet 0/0/1. And here I will issue the IP access dash group. And then I will specify the ACL number. And then also I will include whether it's inbound or outbound. And in my case, I'm going to say outbound. So I will just do some verification quickly. So I'm going to say show IP access list, And you can see that we have configured a new access list. And also if I say show run dash config pipe section, I'm gonna just include the interface ID. We can see that we have applied the ACL 30 in the outbound under this interface, which is connected to server 1. So with that being said, let's go into PC4 and try to reach server 1 and server 2. So I'll say ping 10.2.2.2. This ping, by the way, should work. And it does work accordingly. And now we shouldn't be able to reach server 1. So if I say ping 10.1.1.2, you can see that we are unable to reach server 1 from PC4. Okay, so with that being done, let's move into step number 5, where we need to make sure that the IT department should have access to all departments. However, PC2 must not communicate with any other networks except its own network. That means we would need to go back to router 1. And from here, I'm gonna create a new ACL. I'm gonna say IP access list 10. Actually, we forgot to mention standard. And I'm gonna say 10 permit 10.10.10.11. My apologies. We should actually deny this host. So I'm gonna say 10.10.10.11. And then I'm gonna say permit any. I will issue exit command to get out of the ACL config mode. And then we would need to go to the sub interface that is connected to the IT department. And we would need to apply this ACL in the inbound direction. So I'm going to say interface gig ethernet 0/0/1.10. And I'm going to say IP access group 10. And that's going to be N. So with that being done, let's just do some verification. So I'm going to say show run section, and let's just copy the interface ID and paste it. And you can see that we have applied the ACL under this sub interface. Let's look at the access list that we just created. So I'm going to say show IP access list, and we can also be more explicit about the access list that we want to reveal by saying show IP access list 10. And you can see that we are actually permitting it first and then we're denying it. So I actually need to go back to the global config, and I would need to remove or negate this line of config. So I'll go back quickly and I'm going to say no access list 10 permit host 10.10.10.11. I'm going to hit end, and let's just do some post checks. So I'll say show IP access list 10, and it looks like the whole access list is gone. Okay, sorry about that. Let me just go back and rectify that quickly. Now let's just do another verification. Okay, that looks better. So you can see what we have configured under ACL 10. And what we can do next, we can jump into PC1 and PC2 and do our final checks. So I will go to PC1, make sure that PC1 is still able to reach all other end devices. So I'm going to say ping 10.10.10.11. Let's see if it can reach PC2, and it can reach PC2 successfully. Okay, so we can reach the finance department. Let's check if we can reach the engineering department. We can reach the engineering department. Let's check if we can reach server 1 and server 2. So I'm going to say ping 10.1.1.2. And again, we can reach server 1. Let's check if we can reach server 2 as well. And we have successfully reached server 2. Now let's perform one more test. First of all, I'm going to check if I can reach PC1, which I should be able to, by the way. And I should not be able to reach the finance department, the engineering department, and server 1 as well as server 2. So I'll say ping 10.1.1.2. I'll try to reach server 2. Now I will check if I can reach the finance department and the engineering department. And then finally this IP address 10.10.30.10. And you can see that we have managed to complete our tasks successfully with no issues seen. So that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.